Now let's take a look here at exponents and square roots. We'll look at just a few rules here to help us remember these exponent rules. The acronym MADSPM is one way to help us remember the exponent rules. Let's take a look at the MA. MA means when you see a multiplication sign between like bases, you add the exponents. So y squared times y cubed will be y times y to the 2 plus 3 power, or y to the 5th power. We can see this written all the way out just above. We have 2y's plus y multiplying itself 3 times. That gives us y multiplying itself 5 times, or y to the 5th power. DS means when you see a division sign or fraction, subtract the exponents. So y to the 5th power divided by y squared would be y to the 5 minus 2 power, or y to the 3rd power. Here we can see that again above here. When we're dividing out our y times itself 4 times by y times itself twice, we can cancel 2 y's. We're left with y times y, or y squared. PM means that when you see a base with an exponent raised to a power, you multiply the exponents. For example, y squared to the 3rd power will be y to the 2 times 3 power, which will give us y to the 6th power. Now do take note, this is easy to confuse with multiplication, so be careful there. Let's take a look at that. Y to the 2nd power to the 3rd power is y times y to the 3rd power, or y times y times y times y times y times y, which gets us to y to the 6th power. Now the rules for multiplying and dividing exponents do not apply to addition or subtraction. For example, 2 squared plus 2 cubed equals 12. 2 times 2 plus 2 times 2 times 2 equals 12. It does not equal 2 to the 5th power, or 32. Let's take a look at a few other rules. Anything to the 0 power equals 1. 3 to the 0 power equals 1, for example. Anything to the 1st power equals itself. 3 to the 1st power equals 3. 1 to any power will always equal 1, even 1 to the 3,876th power. That is still 1. A negative exponent means to take the reciprocal of what would be the result as if the negative weren't there. For example, 2 to the negative 2nd power, we can rewrite as 1 over 2 squared, or 1/4. Taking that negative out of there, changing that 2 over 1 to its reciprocal, 1 over 2 squared will give us 1/4. A fractional exponent has 2 parts. Just like any other fraction. The numerator is the power the base is raised to, and the denominator is the root of the base. For example, 8 to the 2/3 power. We can rewrite this as the cubed root of 8 squared, or the cubed root of 64. 4 times 4 times 4 is 64. When we are calculating the value of a root, we're not looking for what number multiplied by itself results in the number under the radical. For example, the cube root of 64 is 4 because 4 times 4 times 4 is 64. What number multiplied by itself results in the number under the radical? When you see the square root sign, that means to take the positive root only. So the square root of 9 would be 3, not negative 3. Square roots work just like exponents. You can always multiply and divide roots, but you can add and subtract only when it's the same root. For example, we can multiply together the square root of 8 times the square root of 2. Bring them together under the radical sign, we get the square root of 16, or 4. The square root of 1 divided by 4, we can break this down into the square root of 1 divided by the square root of 4, which will be 1/2. And the square root of 300 is the same as the square root of 100 times the square root of 3. Notice we factored this down to a square root here that will simplify to a whole number. This will be 10. The square root of 100 is 10. We keep the square root of 3. The answer is 10 square roots of 3. With addition and subtraction, 3 plus 2 is 5. We have the same roots, so we can add those. That would be 5 square roots of 2. This is an understood 1 here in front of the square root of 3. So 4 square roots of 3 minus 1 square root of 3 will give us 3 square roots of 3. Notice we do not have the same root here in this example, 2 square roots of 3 plus 3 square roots of 2, so this is not going to be added as such. Now let's take a look at our exercise. We're going to apply these rules. Let's begin with A. A is 3 to the third power, or 3 cubed, times 3 to the second power, or 3 squared. 3 cubed times 3 squared. Here we'll go back to the MA part of MADSPM. When you see a multiplication sign between like bases, add the exponents. This will be 3 to the fifth power. Let's try B. 3 cubed divided by 3 squared. Here we'll go back to the division. That's DS. When you see a division sign or fraction, subtract the exponents. We can subtract 3 minus 2. This will get us to 3 to the first power. C is 3 cubed to the second power. We're raising an exponent to a power. So now we get to use the PM part of MADSPM. When you see a base with an exponent raised to a power, multiply the exponents. 3 times 2 is 6. This will be 3 to the sixth power. X to the sixth power times x squared. Here we're multiplying again. The only difference is we have variables. We'll keep that x as our variable, and now let's add them. The MA part of MADSPM shows us to add the exponents when they are multiplying one another. D will be x to the eighth power. 6 plus 2 is 8. E is x to the sixth power divided by x squared. When we are dividing exponents, we subtract them. This will be x to the fourth power. 6 minus 2 is 4. We'll keep that same variable x. F is x to the sixth power to the second power. We multiply them when the exponent is being raised to another exponent. 6 times 2 is 12. This will be x to the 12th power. The square root of 8. Let's go ahead and factor that out. This will be the same as the square root of 4 times the square root of 2. Notice we're doing this because the square root of 4 can simplify. This can simplify to a whole number, 2. That will leave us with 2 square roots of 2. Here we ask ourselves what number times what number times what number is 64. But let's keep in mind our negative times positive rules. For an odd amount of negatives times positives, we'll end up with a negative number. 3 is an odd number, by the way. For an even amount, it would be a positive number. For example, negative 2 times negative 2 is 4, but negative 2 times negative 2 times negative 2 is negative 8, because we have an odd amount of negatives multiplying one another. Keep that in mind here. So this will be negative 4. Negative 4 times negative 4 times negative 4 will get us to negative 64. The cubed root of negative 64 is negative 4. The square root of 12 plus 5 square roots of 3. Here again we want to factor out our square root of 12. Let's simplify that to the square root of 4 times the square root of 3. This can simplify to 2, so we end up with 2 square roots of 3 plus 5 square roots of 3. 5 plus 2 is 7. Our answer is 7 square roots of 3. J is y cubed. The square root of y cubed. Here again we're going to bring out our y. There is an understood 2 here. When it's not written, that's a square root. So the square root, we can pull out, let's pull out a y, 2 y's here. Because this will be the same as the square root of y squared. Times the square root of y. If we expand that out, notice this will simplify to just simply y. The square root of y squared is y, which leaves us with y square roots of y for our answer. J is y square roots of y. The cubed root of negative y cubed. Again, this is very similar to the cubed root of negative 64. As in, we have the odd numbers multiplying one another to get to a negative number. So we know it's going to be negative, and we know it's y, so this will be negative y. Negative y times negative y times negative y is negative y cubed. Therefore, the cubed root of negative y cubed will be negative y. And L will end our shorter exercise here on L. The square root of x squared times y plus 5x square roots of y. Remember, there is an understood 2. This is a square root. Now we can factor out a bit. For example, the square root of x squared will simply be x. Let's bring out that x square roots of y, plus 5x square roots of y. Now we can combine like terms because we have the same roots. Let's add 1x plus 5x. This will get us to 6x. And we still have our square root of y inside of the radical. Our answer is 6x square roots of y. Now let's see how this looks on exam day. How might we see these concepts being applied on some test questions, some test problems? Let's take a look at number 3, for example. If 3 to the 4th power equals 9 to the x power, what is the value of x? Here the question is asking for the value of a variable in an equation involving exponents, so we'll go back to our exponent rules. When we're given equivalent exponent terms, by the way, with different bases, we can rewrite the exponent terms using the same base. For example, let's rewrite 3 to the 4th power as 3 times 3 times 3 times 3. equals 3 times 3 is 9, times 3 is 27, times 3 is 81. So 9 times what is 81? 9 times 9 is 81. We could rewrite this as 3 times 3 times 3 times 3 equals 9 times 9. Therefore, 3 to the 4th power equals 9 squared. X is equal to 2. Now, an alternative way of doing this would be to calculate 3 to the 4th power equals 81. If, for example, 3 to the 4th power equals 9 to the x power, then 81 will equal 9 to the x power. X is still equal to 2. A is our answer. Great, let's try number 6. In the equation above, what is a possible value of m? The square root of m squared plus 39 equals 8. Here we are going to solve for m. Let's square both sides to get rid of our radical. This will leave us with m squared plus 39 equals 64. Now we can subtract 39 from both sides of the equation. This will leave us with m squared equals 25. Now let's go the other way and take the square root of both sides to get rid of this m squared. This will leave us with m equals 5. Square root of 25 is 5. M equals 5. Or answer choice C. C is our correct answer. Great, let's take a look at number 5. If 3 to the x to the 3rd power equals 3 to the 15th power, what is the value of x? Here we're looking for the value of a variable. When dealing with exponents, we're going to refer back to our MADSPM rules. The PM part of MADSPM, the acronym, will indicate that raising a base with an exponent to another power means to multiply those exponents. So using the MADSPM rules, 3x to the 3rd power equals 3 to the 3x. Let's change that to 3 to the 3x will multiply 3 times x. Do take note, this is calculator allowed. This is what the symbol means. The calculator symbol means that this section would allow the use of a calculator. Let's write that down. 3 to the 3x power So if 3 to the 3x power equals 3 to the 15th power, then 3x equals 15. We can divide both sides by 3 now to find that x is equal to 5. 15 divided by 3 is 5. The correct answer is B, 5.